In this section, we are going to talk about increasing and decreasing functions. So what we're going to do for these, I'm going to go straight into some examples and then show you what increasing and decreasing looks like. So we are going to determine the open intervals where the function is increasing, decreasing, or constant. So we are actually looking for an interval of x values. And by increasing, I mean that the graph is increasing from left to right. So on this graph for number 1, you'll notice that there's a variety of things happening here. So we start all the way on the left side, and it goes up right up to -2. Then it goes straight across, which we call constant, up until +2. Then it goes up again. Then it goes down. So I actually just divided my graph into 4 parts. Those are where our intervals are different. So for example, my first part, from anything less than -2, is going to be what we call increasing. And even though there's no arrow on the end, we can't assume that it stops at -7. We actually have to assume that it goes on forever. The only time when you can assume that it stops is if there's an endpoint. So the way I'm going to write this interval, and remember they said open intervals, which means that we have parentheses, not the square brackets. It's going to start at -infinity. That's like the lowest possible value ever. And from -infinity up until -2 is where it's increasing. So that's this whole part right here. That's where it's increasing. From there, the graph actually, between -2 and 2, it doesn't change at all. So that's where we say that it is constant. And once again, I'm going to write this in interval notation as -2 to +2. The next part, I have just a little tiny piece from 2 to 3 that is increasing again. So I'm going to write that as the interval 2, 3. Finally, I end up starting at 3 and going on and on and on. I don't know where the graph ends. I'm going to assume it keeps going down. And so I say that it's decreasing because it is going down from left to right. And it's decreasing starting at 3 and actually ending at infinity. So if you're feeling pretty comfortable with this, go ahead and try 2 on your own. If not, that's okay because I'm going to go over it. So I'm going to start by splitting my graph off into parts. I'm going to start with this one and this one. And actually, I kind of end here, so I'm going to split that into a part too. So then you might notice if you look at this graph, there's actually nowhere that it's increasing. Kind of an interesting thing. However, it starts off and it is going down. It's not decreasing very fast, but it is decreasing a little bit. So it is actually decreasing from -infinity to +1. From there, you'll see it stays constant. And it's constant from 1 to 3. Finally, at the very end, it goes from 3 to 5, and it decreases there. It doesn't go any further than that. There's an end point there, so I'm going to stop at 5, but those are my decreasing intervals. Okay, I want to discuss just one more thing here, and it's kind of related to increasing and decreasing. This is called relative maximum and minimum values. So we're just going to do this one example. I'm going to ask you to approximate the relative minimum and maximum values of the function. So usually you hear minimum and maximum as like only one value, but in this case, they're not going to be the absolute maximum or minimum. It's only going to be relative to other points on the graph. So what I mean is, if you look on the first part of the graph, I start decreasing until I get to the point where x is -4, and then I increase. So that point at -4, +1 right there, this point right here, is going to be what I call a relative minimum. And you'll notice that I have another relative minimum, which is right here. And that one is at 1, 0. Now, the relative maximum is going to be my little peak right here. I keep increasing, increasing, increasing. Then when I get to x equals -2, I don't go any further up, I start going down. So this is going to be what I call a relative maximum. And it's at -2,4. This is actually all I have to do for this section. So you just need to figure out where the peaks, the top of the peaks, are going to be the maximum. The bottoms of those valleys are going to be your minimum values. And one other little comment I want to make, just so you don't get confused between this slide and the last slide. Here, these values that I have are points on the line. On the previous slide, I had intervals, which was a range of values. So just make sure that you know the difference. The minimum and the maximum are always going to be 1 point each, whereas the previous page, the increasing and decreasing, are going to be an entire interval. People sometimes get confused on these because they're written the exact same way, but just be aware that they are actually different things.